In 5.7, we're going to review the Pythagorean theorem, okay? The Pythagorean theorem, remember you guys, is specifically for right triangles, and it states, in a right triangle, the sum of the squares of the measures of the legs, so if you take the square of the legs and add them together, it's going to equal the square of the measure of the hypotenuse. It'll equal the hypotenuse squared. You guys are very familiar with this form. A squared plus B squared equals C squared. Remember, A and B are going to be your legs. C is going to be the hypotenuse. So we're going to do a couple examples here. I want you to go ahead and do the first example. Write out your Pythagorean theorem and then fill it in and then come back. Alright, so you should have had A squared plus B squared equals C squared. What you should notice is that your 9 and that your x are going to be your legs, so we're going to plug those in. X squared plus 9 squared, and then across from the right angle is always the hypotenuse, so it's 15 squared. Okay, so we get x squared plus 81 equals 225. Subtract the 81, you get x squared is 144, and to unsquare a square, you guys, you take the square root. Now remember, it's positive or negative 12, but distance can't be negative, so your x is just going to equal 12. I want you to try this one. Be careful of this. It's the same concept, but be careful. Okay, so what you guys should have done is written your a squared plus b squared equals c squared. Plugged in your legs, so you've got 4 here and x minus 2. That's what I did here. Now the x minus 2 squared has to be expanded out. That's x minus 2 times x minus 2, which means you guys are going to have to do some foiling. So this is what we get here, the x squared minus 4x plus 4, so that's where this comes from. Once we get to this point, you should have combined like terms. So you have x squared minus 4x plus 20 equals x squared. And you should have noticed that with the x squared on either side of the equal sign, you can actually cancel them out, leaving you with negative 4x plus 20 equals 0. Now this is simple. Bring your number over and divide. You should have gotten that your x is going to equal 5. Okay, for this example, they tell you that Randy is building a rectangular picture frame. He wants the ratio of the length of the width to be 3:1, and then the diagonal is supposed to be 12. So they gave you a for sure, the diagonal is 12. And then the ratio of the sides, length to width, has to be 3:1. Remember, you guys, the ratio is what you see reduced. Okay, so we have to multiply both of those by the same number in order to get back to my original. If you remember, we used to multiply these by x. So length to width, we've got 3x by x. Now we can use our Pythagorean theorem to help us actually figure out to the nearest tenth of a centimeter how wide the frame should be. A squared plus b squared equals c squared. We have x squared plus 3x squared equals 12 squared. Remember, it's the whole thing being squared. Alright, so we have x squared plus 9x squared equals 144. I would like for you to solve this, please, and then we'll see if we come up with the same answer. So give me a pause, we'll see if we come up with the same answer. Okay, you guys, so we set it up, the a squared plus b squared equals c squared. So what you should have done is combined like terms. You should have gotten 10x squared divided by 10, and then took the square root. So to the nearest tenth of a centimeter, we should have gotten 3.8 centimeters. When doing the Pythagorean theorem, you can actually simplify this or figure out your answers by remembering your Pythagorean triples. Pythagorean triples are just simply 3 whole numbers that actually satisfy the a squared plus b squared equals c squared. Remember, c is going to be the greatest number because it's your hypotenuse. So if you can remember these, it's really easy to help you solve the Pythagorean theorem without actually having to go through all of the steps. Alright, so what this is actually saying is, for example, let's say I've got the lengths 3, 4, and 5. 5 is the largest number, so clearly 5 will be your C. If I were to say that one of my legs is 3 and I wanted to find the other, by knowing my Pythagorean triple, I would be able to see that the other leg would be a 4. Now watch. 3 squared plus x squared equals 5 squared. When you solve this, 9 plus x squared equals 25. you get that x squared is 16, and lo and behold, when you take the square root, you get your 4. So by remembering your Pythagorean triples, you can remember which numbers are where on triangles. Now this also works if you have multiple of these sides. So for instance, if this was a 6 and a 10, you could probably guess that this side would be an 8 because of your Pythagorean triples. Both sides are just multiplied by 2. Alright, so keeping in mind these Pythagorean triples, find the missing side lengths if the Pythagorean triple is around. Now remember, our Pythagorean triples were on the previous slide. One of your Pythagorean triples was a 7, 24, and 25. And if you take a look here, you'll notice that one of your legs is 14, one of your legs is 48, and you have to find the hypotenuse. Well, using your Pythagorean triple, you should see this Pythagorean triple right here. If I multiply by 2, I would get 14, 48, and then if I multiplied the 25 by 2, you should end up with 50 as your missing side. So the missing side would be 50. You could also prove this by taking 14 squared plus 48 squared and solving it for your hypotenuse. So what I would like for you to do is do this example now, find the missing side length, and then tell me if the side lengths form a Pythagorean triple. So right off the bat, I don't notice anything particular about this one. What I can do though is I can go through and do my Pythagorean theorem, and I can check to see if it's a Pythagorean triple. So x squared would equal 128. When I take the square root of x squared, do I get a whole number? Square root of x squared. When I take the square root of 128, do I get a whole number? No, this is actually 64 times 2, so this would be 8 square roots of 2. So no, this is not a Pythagorean triple. Alright, so you guys, what would a theorem be without its converse, right? So the converse of the Pythagorean theorem states, if the sum of the squares of the lengths of two sides of a triangle is equal to the square of the third side, then the triangle is a right triangle. So before, what we said is a squared plus b squared equals c squared if it's a right triangle. Now we're flip-flopping. We're saying if we show that when we add these legs and add the square of these legs and it equals the hypotenuse squared, then it's definitely a right triangle. We can use this to prove that it's a right triangle. So just a refresher, Pythagorean theorem says if it's a right triangle, then a squared plus b squared equals c squared. The converse flips it. If a squared plus b squared is c squared, then we proved it's a right triangle. But we always don't have a right triangle. Okay, we can have an obtuse triangle or an acute triangle. That's where these wonderful Pythagorean inequalities come from. The first one we know. We know that if c squared is equal to a squared plus b squared, we know that it's a right triangle. Okay? The next two are going to help us figure out if it's acute or obtuse. If c squared is larger, so let's say you run through, you do your a squared plus b squared, you compare it to your c squared. If it's greater than the a squared plus b squared, you have an obtuse triangle. If when you run this through, you notice that your c squared is actually smaller than the sum of the squares of the legs, then you have an acute triangle. We're going to practice a couple of these, and then, yeah, we'll let you practice on your homework. Okay, so here we go. I want to know if the measures of the side could be a triangle, first of all. And then, if so, is the triangle acute, obtuse, or is it right? So first things first, how can we tell if it's a triangle? Well, we can tell if it's a triangle when I add the two smaller sides. So the two smaller sides, the two legs, if it's greater than the hypotenuse. So let's take a look. Is 40 plus 96 greater than 104? Hopefully you said yes. So this is a triangle. Let's take a look down here. The two small sides, 3.8 plus 4.1, is that greater than 5.2? Hopefully you said yes. And then is 5 plus 8 greater than 17? No, it's not. So this is not a triangle. Because we figured this out, we don't even have to do this problem. There's no more to do. Okay, so I'm going to do the first one with you, and then I'm going to have you work on the second one, and then we'll see if we end up with the same answers. So first things first, I know this is a triangle, so now I have to figure out what type of triangle it is. Well, in these cases, remember we're going to take our a squared plus our b squared and we're going to compare it to our c squared. Okay, so let's do this. 40 squared plus 96 squared. This is 1600 plus 9216, which gives me 10,816. Oops, I added an extra 1. Let me erase some of that. Sorry, 10,816. Now let's compare it to our c squared. Our c is 104, so 104 squared. When you take 104 and square it, you get 10,816. Now let's compare them. Well, it just so happens that these are equal. If a squared plus b squared equals c squared, this is a right triangle. I would like for you to do b, please. Pause it and then come back. Okay, so a squared plus b squared, you have your 3.8 squared and 4.1 squared. When you add these together, you get 31.25. Your c squared, so you take your 5.2 and square it, you get 27.04. Now let's take a look. Let's compare a squared plus b squared to c squared. What you should notice is that c squared is smaller. If c squared is smaller, that makes this an acute triangle. Okay?